Hi friends, welcome back to Edupedia world. The previous two lectures we have seen what is critical angle and also what is total internal reflection. So today's lecture we will not see any more theory. We will practice some numericals on both the concepts. Let us see them. The question at hand states that we have a isosceles right-angled prism. This is the prism and it is kept in front of a object AB. This is the object AB which is shown here, and we are asked to draw the ray diagram to find the image. Where will the image be formed? That is what we are asked to find. And it is stated that the critical angle for glass air is 42 degrees. So what this means is that IC is 42 degree. Okay. Now since it is a right angled prism and this is the 90 degree and it is an isosceles, so this and this will be 45 degree each. Okay. 45. Now the ray of light, let us trace the ray of light which falls perpendicular on the surface. If it falls perpendicular, then there will be no deviation and it will strike the ray of light will strike here. At what angle? Let us find out. Let us draw the normal here. So this is 45 degree. This means this is also 45 degree. Since this is normal, this is 45 degree. Now as this angle is 45 degree, that is the angle of incidence here is 45 degree more than the critical angle. 45 degrees more than the critical angle. Therefore what will happen is a total internal reflection will take place at this surface. Total internal reflection, therefore the law of reflection will follow. This is 45 degree. The angle of reflection will also be 45 degree, and as a result what will happen? The ray of light will move parallel to the base. This is 45, so this is 45. The whole thing will be 90 degree and it will move parallel to base. Let me write it 45. This is also 45. I am not writing it down. Now what is happening when it moves parallel to the base? It is striking this surface, and let us draw the normal here. The normal here, what will it do is, we know this is 90 degree. We know this is 45, therefore this has to be 45. As a result, this is 45, which results in this being 45 degree. Again, the angle of incidence is more than the critical angle. And since it is again more than the critical angle, total internal reflection will take place at this surface too. When total internal reflection takes place at this surface, the angle of incidence being 45, the angle of reflection will also be 45, and it will follow this path, hit this surface perpendicular, no reflection, no refraction at the surface takes place. It keeps moving straight forward here. Similarly, what will happen is this point, the B point, will also trace perpendicular to the surface, no deviation, hits this surface, makes 45 degree with the normal, same as here, is internally reflected totally, hits here, again internally reflected totally, moves this direction, normal, goes this direction, and ultimately what will happen is that we will get the B dash point here, that is B is reflection, and A dash point here, that is A is reflection, and we will get a inverted image A dash B dash. So if this was positive direction image, then this is a negative, rather if this was a positive direction object, then this is a negative direction image. So what we see in this example is that a prism is used like a mirror, though the image is getting inverted, but we are getting the image with complete brightness, with maximum brightness. Why so? Because here total internal reflection is taking place in both the surface rather than normal reflection. So this is what we discussed in the previous lecture, that we can use total internal reflection as an alternative to mirror. Okay, so this example shows clearly how to draw the ray diagram and what is the importance of the critical angle. Since the angle of incidence was more than the critical angle, total internal reflection took place. Suppose that this angle were less than 45 degree, rather less than 42 degree, then refraction would have taken place and the ray of light would have moved somewhere in this direction. Then the case of total internal reflection would not have occurred. Okay, so next let us see another numerical. This question states that the critical angle for a pair of medium is 45 degree. So what do we know? We know that IC is 45 degree. And we need to find the refractive index of the denser medium with respect to the rarer medium. So what do we need to find? Refractive index denser with respect to rarer. This is needed. Now we have seen in the lecture that the relation between the critical angle and the refractive index is given by sine of critical angle is equal to 1 upon the refractive index of denser medium with respect to rarer medium. If we replace it, what we will get is sine of 45 degree, which is 1 upon root under 2 is 1 upon refractive index denser with respect to rarer, and ultimately this means our refractive index, I'm not writing the subscript, but the refractive index of denser with respect to the rarer medium is root under 2. So we have found the first part, that is refractive index of denser medium with respect to the rarer medium. Now the second part of the question says that if the angle of incidence is 30 degree and light is traveling from the denser to the rarer medium, what is the angle of refraction? So let us frame the question in the form of a diagram. Let this be the denser medium, this be the rarer medium. We know that the refractive index of dense with respect to rarer is root under 2, and we are provided with the information that the incident angle at the interface is making an angle of 30 degrees. So this I is 30 degree. We are supposed to find the angle of refraction. We are supposed to find R. It is actually pretty simple. Why? Because we can directly apply Snell's law. Now let us see how that works. The refractive index of denser with respect to rarer is mu dr. So mu dr times sine of I will give me, since I have taken this as the relative refractive index, I can take 1 here times sine r. Okay, I hope you understand why I took 1 here, because I have already taken the reference refractive index here with respect to the rarer medium. So obviously this has to be 1. Now we know this value. What is this value? This value is root under 2. Do we know the angle of incidence? Yeah, we do know that as 30 degree. So sine of 30, and that should be equal to sine of r. Okay. Upon simplification, sine 30 is 1 by 2, that is half. So root 2 upon 2 is sine r. Root 2 upon 2 is basically, so I will reverse it, sine r is root 2 upon 2 is 1 upon root 2, and r is basically sine inverse 1 upon root 2, and 1 upon root 2 sine inverse is 45 degree. So what we get is that the refracted ray, the angle of refraction is 45 degree. How can we verify, or how can we at least make a guess whether we are in the right direction or not? The fact that the angle of refraction turned out to be more than the angle of incidence while moving from a denser to a rarer medium indicates that the solution must be in the right direction. Okay, so here we have used two concepts. The first concept is we have used the critical angle, value of the critical angle, to determine the relative refractive index, and then we have used that relative refractive index to further find the angle of refraction given the angle of incidence. Okay, so now finally, before we close this chapter, we will see another example. We will draw another ray diagram, and we'll see total internal reflection as well as refraction in this particular example. The final numerical which we are going to see in this chapter says that a ray of light strikes an equilateral glass prism as shown. So this prism is equilateral, that is, this three angles are 60 degree each, and the ray of light is striking this surface. Let us call it A, B, C. The prism is named ABC. Then the ray striking surface AB perpendicular. We are asked to find the draw the complete ray diagram. How will the ray go? And we are also given that the critical angle of incidence for this glass prism is 42 degrees. Fine. Now the first point of impact, that is the surface AB, we see that the angle of incidence is 0 degree, that is, the ray of light is going perpendicular to the surface. Therefore, the ray will continue to move in the same line of path, same line, and it will strike the surface AC somewhere around here. Pardon me for my drawing, this is actually a straight line. Okay, so now at what angle, what is the angle of incidence at this surface? Let us calculate. We know this is 60 degree, we know this is 90 degree, therefore this has to be 30 degree, right? Now given that this is 30 degree and this is our normal, this has to be 60 degree. Now here the angle of incidence turns out to be 60 degree, which is more than the critical angle. Okay? Therefore, what will happen is that the angle of reflection will also be 60 degree. A reflection will take place. Okay? And reflection, what does that mean? That means that given this is 60 degree and given this is 60 degree, my angle of reflection has to be 60 degree. This will be 60 degree. This is 60, therefore this will be 30 degree. And as a result, it will strike this surface perpendicular. Okay? Now this surface it will strike perpendicular, and since perpendicular striking means that the ray of light will traverse through undeviated. So refraction will take place at this surface, but since the angle of incidence is 0 degree, the angle of refraction will be 0 degree and the ray of light will just pass through undeviated at the surface BC. Therefore, we see that the total ray of the light is this straight line striking here, undergoing total internal reflection at 60 degree, and as a result it strikes this surface perpendicular and keeps going undeviated. Okay, so with this example I think we know a lot about critical angle and total internal reflection by now, and I'll close today's chapter at this example. The next chapter we will begin lenses. We'll see what lenses are, the properties about is, how image is formed using lenses, and all the details about it. So till the next lecture, have a great day. Goodbye.